If you're enjoying these videos, subscribe. Let YouTube know that I'm doing a good job by subscribing to the channel. Plus, you'll get notified when I have new videos coming out. And finally, if you're enjoying what I'm doing, give it a like. Just click on that thumbs up, and that way YouTube knows that you like it, and they'll pass it along to other people that might enjoy my content as well. I really appreciate it. Thank you again. Let's get started.
Allow me to introduce our guest speaker for this morning. Our guest speaker is Dr. Celia Medina. She is a professor in entomology at the University of the Philippines, Los Baños. She teaches insect ecology, pest management, general entomology, and research methods in agriculture. She has supervised 47 student researches since 2008. She is very active in research from pest management to climate change impacts. Her researches in crop protection mainly involved insect pests of mango and coconut that ranged from generation of fundamental biological information up to their eventual application in pest management. To it, her researches on the non-destructive detection of pests of mango pulp weevil led to the establishment of the mango pulp weevil detection centers in Palawan, and her studies on the ecology of coconut scale insect led to the development of software adopted by the Philippine Coconut Authority for pest counting and monitoring. She also contributed to the knowledge and management of mango leaf hoppers, fruit fly, thrips, and cecid fly in mango. She has been active in advocating insecticide resistance management in mango and has published Farmer's Guide, web application, and trainer's manual on this matter. Let us all welcome our guest speaker for today, Dr. Celia Medina. Good morning, ma'am.
Good morning, Nico. Good morning po sa inyong lahat. So, para tayo ay, pwede na ako mag-share. Tayo magsimula na. Nakikita ba? Maayos ba ang aking, nakikita na ang aking sinishare?
Yes, ma'am. Kita naman po.
Okay. Okay. So, my topic is the management of mango cecid fly. Mango cecid fly cause this damage on mango. These are different kinds of damage at different stages of mango development. And it has been given several names. We call it kurikong for Tagalog speaking. Sometimes they call it kori. Meron ng palayaw ngayon ang kurikong. Tinatawag na lang siyang kori. Sa mga Bisaya, siya ay buti. Tinatawag din siyang nora-nora. And to some, they call it saksak-walis. The culprit, the reason why, the culprit of this damage, of this problem in mango, actually, is a very tiny insect. Can you even see it in your screen? It is a very tiny insect that if you put it in the O, in piso, in your piso, it will fit inside the O in piso. In order to give you a detail about how it looks like, this is how it looks like. It is a typical midge. A midge is a close relative of mosquito, but a midge is very delicate compared to a mosquito. So a typical midge or a typical mosquito will only have 2 wings. Normally, insects have 4 wings, but this one only has 2 wings. It has long legs and long antenna. This individual here that I'm showing you is a male. Okay. Because it has this kind of clasper at the end of the abdomen. So this insect is given several names. It is called cecid fly. Internationally, it is called mango midge. Some people also call it a mango gall fly. In the scientific world, we have scientific names. That is how we call insects, so that we will be able to communicate, scientists will be able to communicate better. And this is called Procontarinea frugivora. Take note that it is Procontarinea. I have seen many people giving names to this insect like Procantarinea. No, it is Procontarinea frugivora. And it belongs to researchers, it belongs, of course, to order Diptera and to the family Cecidomyiidae. This is perhaps where the name Cecid fly came from Cecido. Cecido in Latin means gall. That's why it is sometimes called a mango gall midge or a mango gall fly. But it is not a fly, it is a midge. So this is more for the researchers. Procontarinea species all over the world totals to about 17 in all. And it is mainly associated with mango. It has not been seen in any other plant except mango. And most of the species of Procontarinea are feeding on the leaves, except for 3 species. This Mangiferae, which is found in Pakistan and India, and Frugivora, Mangiferae, feeds on flowers. Frugivora, which is found recorded only in the Philippines, feeds on fruit. And in 2018, there is another species found in China feeding on fruit, and this is named Procticuli. So, ang ating Procontarinea frugivora is only in the Philippines. I have to make a stress on this point. This point should be stressed because many people say that the Procontarinea in fruits and in the leaves are the same. No, they are different. And the ones in the leaves do not feed on the fruits. And the one on the fruits do not feed on the leaves. They are very specialized. So there are 3 Procontarinea species in the Philippines. This is Postulata, that makes galls on mango leaves. Procontarinea robusta, also making galls on mango leaves. And the topic for today, which is Procontarinea frugivora. This is Postulata. And these are the kinds of galls that it makes. Procontarinea postulata makes blister-like galls on the leaves. And this is the most common gall that you will see in mango. Most of the time, it is mistaken as an infection of anthracnose because after the insect has gone out of the blister, it is usually attacked by an anthracnose. But it doesn't cause so much damage to the plant because it will not result to falling of the leaves, and it can only reduce the photosynthetic activity of the plant. The other one, Procontarinea robusta, makes this kind of galls. And these are very distinct and big galls on the surface of the leaves, as well as underneath the leaves. And unlike the the other species of Procontarinea, this pupates inside the gall. So this is Procontarinea robusta. And these two gall-making Procontarinea do not feed on the fruit. So the topic today is Procontarinea frugivora. Procontarinea frugivora produces the corycomb that we are so afraid of, and it produces, but it feeds on the surface of the fruit and not go deep into the flesh of the fruit. But it gives the fruit a very ugly looking appearance. To discuss the management of this insect, this is how I will do it. I will first talk about the insect, its life cycle and behavior. And then I will talk about the reasons why the usual method fail. And at the same time, after I have explained to you why the failure in the control, I will give the recommendation. So these two topics will be discussed collectively, almost simultaneously, one after the other. So you do not expect that I will be having three major topics. Let me present to you now the life cycle. And I would like to present it to you in the context of a mango orchard. So the adult here, which is of course, you know, is coming from the pupa, comes out usually late in the afternoon, around 4 o'clock, 5 o'clock, 6 o'clock. And it does not live long. It lives to a maximum of 3 days. Usually it lives for 1 to 2 days only. So from the time it comes out, it will be looking for a mate. After mating, it will lay eggs. And the eggs are not inserted on the fruit. The eggs are laid on the surface or the skin of the fruit. And these eggs will hatch into its very small larva and feed into the fruit. And the larva will feed inside the fruit until it has grown big. When it has grown big, it will get out of the fruit and become this form, which we call pre-pupa. If the condition is right, meaning there is enough moisture in the soil, it will go into the pupal stage. Otherwise, the pre-pupa can stay up to 6 months in this stage and not pupate. We have seen this in the lab, and we cannot still say how long the insect can stay as a pre-pupa. But the longest that we have seen is around 6 months. So when it has developed into a pupa, then in just 2 to 3 days, it will develop into an adult again. And the cycle repeats itself. So the major question when you are presented a life cycle are the periods of time of development. The egg hatches in 1 to 2 days, usually in just a day. And then it develops inside the fruit, is inside the fruit for 3 to 4 days only. Can you imagine that? The damage, the curicum that you see is caused by a 3 to 4 day feeding of a larva. And then it comes out, it spends pre-pupa for 2 to 3 days only if the conditions are right, and pupates. And after 2 to 3 days of pupation, it becomes an adult again. If you have to add this, and this, you will come up with 8 to 12 days. On the average, one life cycle will be 10 days. This is very short for an insect. So how will you use this information for management? Let me now explain to you again the life cycle and behavior of the insect, but this time it will be in relation to mango. Normally, the stages of mango development is expressed as Daffy. You will see here 10 Daffy, 17 Daffy, 24 Daffy, etc. Daffy is days after flower induction. So it is by convention that we refer to the reckoning of the age of the flower or the fruit is from the time that the tree was induced to flower. So the first bud appears usually at 10 Daffy. And you should understand that these are approximations. The 10, 17, 24, 28, 32 are just approximations. It could be early, it could be late, depending on the climatic conditions. So if it is warm, it could be early. If it is a little bit cool, it could be later. If it is a little bit rainy and cool, it will be much, much later. So these are approximations. The number are not exact. And these are only approximations on when the flower or the fruit comes into these kinds of stages. So this is flower development. And this one has a set of insects attacking at this stage. But this is not the topic for today. The topic for today is more of the one occurring during fruit development. And in fruit development, take note, these are 32, 40, 50, 75, etc. And the Cecid fly occurs during the stages from 32 to 75 Daffy. And aside from this insect, we have another set of other insect pests attacking the fruit of mango. Let me further explain first the difference between this stage, what is called a full bloom, and a post-anthesis. Because as I said, this is the start where Cecid fly attacks. So why is this important? Because this is the time that you have to judge whether should I start monitoring, should I become vigilant about the Cecid fly? And is it 32 or is it something, it is not, as I have said, it is not the number. It is how the plant is exhibiting that stage. When you say full bloom, the flowers in the inflorescence are not open at the same time. The flowers, the inflorescence is said to be in full bloom when more than 50% of the flowers or the florets are open. Look at this. This one has not opened yet, but most of the florets have opened. But take note also that there are florets that are already wilting. This is wilting and this is wilting. And these are the petals. And of course, the ovary of the flower. Okay. Now this is also full bloom. You see, this is a very common pollinator. The blowfly is a common pollinator of mango flowers. So here there is a combination of opened ones and wilting flowers and unopened flowers somewhere here. This is also called full bloom. But the flowers on the tip, the florets, are not opened yet. This is also called full bloom. To mango farmers, they refer to this as kabanguhan because the air is filled with fragrance of the flower during this stage. And this will last for three days or more. This is also full bloom. And this is now what I call the 32 to 35 Daffy, in which Cecid fly starts to attack. You should observe that the petals in most of the florets are now wilting, are now brown. And those flowers that were successfully pollinated are developing into fruits. This is a very nice flower because it looks like there are so many fruits. But in reality, the fruits on the tip of the floret, of the inflorescence, this one is the tip of the rachila, will not develop into a fruit. They will eventually fall off, the ones in the tip. And the ones that will successfully develop are the ones positioned lower in the main axis of the inflorescence. So at this stage, most of the petals are wilting. But take note of this. This is the ovary, which will become the fruit, and it still has the horn, the typical horn-like thing in the ovary. Mango growers call this stage as matanghito. It is not even the stage that they call munggo. This is matanghito because it still has this horn-like thing in the ovary. This is a close-up, and this is now a typical damage of a Cecid fly in this developing fruit. What is sad about this is that, as I have said, this tip of the inflorescence will not develop into a fruit. This usually will not develop to maturity, but they become the breeding ground of Cecid fly. So if at this stage, the population is not controlled, you will have more Cecid fly later on. So this is the time, the 32 to 35 Daffy is the period of time that you or farmers should become vigilant about the attack of the Cecid fly. But the usual practice, because farmers do not know so much about Cecid fly yet, the usual practice is that after pabaon. And usually pabaon happens as late as 26 Daffy. That is the last spraying before the full bloom. After pabaon, the farmer does not come back and do anything, not until the fruit is as big as the next stage. Wait, not yet. Okay. I should first further describe to you this stage. This is the stage that is good to brisk the tree. Alam niyo yung brisking? Brisking, ito yung niyuyug-yug yung puno. If you make yug-yug the puno, this will fall to the ground. And if you pick up one of those, the fruits that fell to the ground, you will see this kinds of damage if you have Cecid fly. This is the damage at 32 to 35 Daffy. So these fruits were not picked from the tree. These fruits fell down to the ground. And as I said, they become the breeding ground of Cecid fly. So this is the usual time that farmers come back and check the trees. And this is the time that they become surprised. Okay, I have a lot of kurikong. And this is quite late. When you have damages like this at 41 to 45 Daffy, you have a 50-50 chance of saving the fruit. I just would like to show how it looks like when a larva just entered the fruit. This is a typical damage. And then that entry hole will become a little bit brown, light brown in color, as the larva develops inside the fruit. And then when the larva comes out, it leaves a hole. This hole is now will heal and become a scar, and it darkens. And that is now what you call kurikong. Because Cecid fly belongs to gall farmers, some fruits will have this kind of galling, a slight galling of the fruit. See, this is an early entry hole. This is a little bit advanced. And this one, the insect has come out. So the damage continues up to 50 to 55 days. This is now when the fruits are ready to be bagged. But then you can still have damage of Cecid fly at this stage. And it can repeat up to 70 to 75 Daffy. If you will notice, here, the kurikong are smaller. The scars are smaller. Why? Because the attack was late. It was attacked when the fruit is already big. But if it was attacked early, the scar will be stretched as the fruit grows bigger. But in this fruit, the attack came later. That's why the scars are smaller. Look at this fruit. These are attacks when the fruit was still small, but there are newer attacks somewhere here when the fruit is already big. So the insect keeps attacking the fruit if they are not controlled early. Okay. To summarize, and if you have to use now your previous learning that there are 10 days on the average from egg to adult, and from 30 to 75 Daffy, that means you have 45 days. So the implication of that is that you have one generation, the first generation, and this first generation of Cecid fly can develop into a second one, a third one, and a fourth one. And as you know, when this happens, when this thing is happening, one individual is not replaced by another, only one individual in the second generation. One individual can lay, we do not know yet how many eggs it can lay. But let us just say there are 1:50 replacement value. One will be replaced by 50 in the second generation, and then by another 50 in the third generation. So as the one generation is completed, there is an increase in the population as one generation is completed. Fortunately, the fruit is not conducive for laying eggs when it is bigger. That's why the population at this, on the fourth stage, can be lower. Okay, so obviously, one of the major reasons of the failure in the usual control is the lack of information on the Cecid fly. That's why they have a late application of control. Let me now go, and there are 3 other reasons why we have a problem in Cecid fly. The second one is insecticide resistance. The third one is the ineffective insecticide mode of application. And the last one is the decline of natural enemies of Cecid fly. And I will tackle this one by one now. So for insecticide resistance and its management, in order to understand this, we need to have a quick review of what is insecticide resistance. Ang insecticide resistance po ay hindi magic na ang isang insekto ay nagtatransform bigla at nagiging iba. Hindi siya magic. Hindi ito ang insecticide resistance. Mas mahigit, ibang-iba ang paraan kung paano nagiging resistant ang isang insect. May tawag ang mga farmers dito. They call this immune. An insect becomes immune. Okay. This is what happens when you spray insecticides. For example, this is a population of Cecid fly at 32 Daffy. You will notice that the population here are composed of individuals. These insects are not all the same. There are insects that are pink and there are insects that are green. The green ones are the ones that are difficult to kill. That means they have in themselves, in their DNA, an ability to not to sequester the insecticide or to detoxify the insecticide. In other words, kahit anong gawin nyo, hindi nyo sila kayang patayin. So, there will be individuals in the population that has that ability. Okay, then you apply an insecticide. So, expectedly, you will say that, okay, the pink ones will die and the green ones will not die. But of course, there are individuals that are siniswerte. Mga maswerte. Kahit sila na, nung mag-spray, nakatago sila. Or, nahuli sila ng dating. Or, nangapit bahay sila. And these are the ones that we call the survivors, and sila ang magiging mag-asawa. And because there are more, the proportion of the resistant survivors versus the susceptible ones are higher, then the offspring, which becomes the population that will attack the fruit at 40 to 45 Daffy, will have more of the resistant ones and less and more resistant ones compared to the first population at 32 Daffy. Okay, let's put that in the context of what you learned and what I have discussed a while ago. So this is now the population at 42 to 50, 41 to 45 Daffy. And if you spray again the same kind of insecticide, you are repeating the story. So more and more resistant individuals are appearing in the population. And you apply again the same insecticide with the same mode of action. And so this population is now what you call the immune. This is now the resistant population. Ito na ang resistant na Cecid fly. Dahil hindi siya tatalaban na. Magtataka na kayo, hindi napapatay. So hindi siya nag-transform. Ang ginawa lang natin, pinadami natin yung mga Cecid fly na hindi tinatalaban dahil meron silang DNA para hindi talaban sila nung insecticide with the same mode of action. Sadly, when we had a survey of practices of farmers tend to use the same insecticide over and over. And there are several factors why this happens. Because they have already borrowed pesticides at the start of the season. And these are the only insecticides available to the farmers. That's why they keep repeating and repeating their insecticides during these stages of fruit development. Unknowingly, they are breeding a more resistant population of Cecid fly. That's why there is a failure of control. And of course, the solution for this is insecticide resistance management. With DA bar, FPA, and UPLB, we came up with a guide on insecticide resistance management for mango. This guide is not only for Cecid fly, but also for other insects. It also includes other insects of mango. And this is published in November of 2018. It has several steps. It describes to you the different steps on how to use, how to do IRM. And it will give you a recommendation such as this. If we change the kind of insecticide that we spray each time, this will not happen. So, babalik na rin lang natin. So if you use MOA 5 first, you should use MOA 2 next, you should use MOA 3 next, and you should use MOA 4 next. And you will not develop this kind of resistant population. You will be having maybe similar to this each time you spray. So it will always be, there will always be a kill that will happen. But then insecticide resistance management is quite complicated because you have to know what is mode of action. So when I am invited to talk about this, I started to use and teach farmers MOA, not Mall of Asia, not Memorandum of Agreement, but mode of action. And previously, it's difficult to teach this because, and so I have devised a way of color coding the different MOA. And we came up with different forms. This is the latest form, which is an insert in the guide to tell farmers, okay, these kinds of brands, these are brands, and these are the active ingredients will fall in the same MOA. These are the same MOA as long as they have the same color. Because of this, FPA pushed for the inclusion of MOA now in the label. This is not available in the Philippines, by the way. I just want to show you that the label of insecticides, fungicides, other pesticides, based on the policy of the FPA, should now include MOA in the label. So we were overtaken by events. It is now, we can now say, okay, you do not use the same number after the other. So you have to change the number. That is now the rule if you want to follow alternating MOA. But then it should be based on the past use of insecticides. So you have to analyze that. To simplify matters, we have made a web application. And this is the web application. If you will type in the search box of your cell phone, of your computer, https://mango-irm.com, it will ask for what insecticides you have used in the past, and it will give you recommendations of what to apply next. Wait, I'm sorry. I think I wanted to show you an example of the output. Meeting. Okay. Anyway. Nawala. Sorry about that. Now, the third reason why we fail in the control is the ineffective insecticide mode of application. What do I mean by that? This is the usual way that we apply pesticides on mango. And this is described as diluted cover spray. You have a power sprayer. You have drums where you mix the insecticide, where you dilute the insecticide, and you have this pole, and you have this spray. And this is spraying is covering as much surface of the tree. That is basically the aim of diluted cover spray. You use a lot of water and you use a power sprayer in order to cover as much area of the mango parts like the leaves, the flowers, or the fruit. This is the mode of application of insecticide that we do. It's a diluted cover spray. That's the description of that. And when farmers check after spraying, this is what they see. Okay, the leaves became wet because from afar, it will look like it is wet. And because they are spraying up to run off hanggang tumulo yung insecticide papunta sa lupa. Then if you inspect the leaves, this is what you see. So okay, they think that they have already protected the tree. They have a cover. They have given the tree a cover spray. Let me show you here a video of what is really happening. This is on the fruit. Observe the droplets on the fruit. So you see the droplet, the water are forming big droplets on the fruit. When the wind blows, and if you give this one minute, that these droplets will fall off, will roll over and fall off. Close up, this is what you see. Remember how small our insect is. The aim of diluted cover spray is to coat the fruit because we will never, maswerte tayo kung tamaan natin yung insekto. Ang insekto matalino. Pag nag-i-spray ka, aalis. Pagkatapos mo mag-spray, babalik. Pagbalik niya, kailangan ang iyong prutas ay na-coat ng insecticide. But that is not what is happening. This droplet will, in 1 minute, will roll off and fall to the ground. And we are left with no insecticide cover spray on the fruit. The shortcut to this is just to add a spreader, a wetting agent into the insecticide mixture. If you add one, this is without spreader sticker, and this is with the spreader sticker. This is with the same amount of insecticide, but then this one has a better cover spray than this one, using the same amount of insecticide mixture. And this is what happens if you use a spreader sticker versus one without a spreader sticker. Because the spreader sticker makes this droplet spread rather than form a drop like this. Because it removes the surface tension of the water. The spreader removes the surface tension of the water such that the water will spread on the surface to which it is dropped. Okay, so now let me go to the fourth point. So to continue the story, when you spray, most of the water falls to the ground. And what do we see? What do we usually have in the ground? It is the prepupa and pupa of Cecid fly and other insects that pupate on the soil, like thrips. When I first studied Cecid fly, I collected many larval pupal parasitoids. I could not collect this anymore. We are losing the larval pupal parasitoids or the natural enemies of Cecid fly. And as of now, we have 3 species that are identified and one unidentified one. So we are losing our ally, yung ating kakampi. Ito ay ating kakampi. They kill insects, the Cecid fly, that escape the pesticide application. Unfortunately, sila ang unang namamatay kesa sa Cecid fly. And there could be more damages that are happening due to excessive use of pesticides in mango. This is one experiment in which we look at how much insects are killed every time we apply pesticide on the tree. And it is so sad to see how much insects are killed versus the pests. It's not, we are killing only a few pests, but many of the non-target species. So basically, we are killing the agroecosystem of mango. So to solve this, we should use insecticide judiciously. We should follow the recommended rate. Huwag po tayong maging chemist. Kanya-kanyang timpla. Magtitimpla tayo ng kalahati nitong recommended rate nito, kalahati nun, at iniisip natin kalahati at kalahati magiging isa. Umiimbento tayo ng bagong insecticide. Sinasabi ko madalas sa mga seminar ay kung uubra yan, nauna na yung company na gawin yan. Dahil siyempre humahanap sila ng paraan para maging mabisa ang kanilang produkto. Kaya para i-save kayo sa mga ganong experiment, wag na po ninyong gawin. Follow the recommended rate. Kasi ang kalahati ng isang insecticide at kalahati nun, ibig sabihin hindi makakamatay. Kalahati lang ang inilagay mo. Ang iba, ganito ang sinasabi. Bakit niyo po hinaluan ng ganitong insecticide yan? Para paamoy. Ang insekto po natin ay hindi pareho ng ilong natin. Ang mabaho sa atin ay maaaring hindi mabaho sa kanila. Kaya yung mga paamoy, paamoy siguro may magagalit ang iyong kapitbahay dahil mabaho ang iyong ini-spray. Pero yung mga yon ay wala pong basihan. Dahil hindi pareho ang ilong natin at ang ilong ng insekto. At mag-spray lamang kung kinakailangan. At ito ay palagi kong sinasabi, dapat nag-o-observe ng pre-harvest interval. Alam kong mahirap sundin ang recommended rate. Bakit? Dahil maraming insecticide sa label. Pag tinignan mo ang label, ang recommendation ay base sa 16 liters. Hindi nila inisip na ang magmamangga ay hindi naka-backpack na 16 liters. So kailangan pang mag-compute. Doon po dito in our guide, we have made this conversion table so that when the label says 1 tablespoon per 16 liters, ito yung knapsack. Ang ibig sabihin niyan sa isang drum ng tubig is 125 ml. Ganon din pag iyan ay pag naman yung iba pang mga ratio na mga rekomendasyon. So, doon sa guide na ginawa namin, mabilis mag-compute. Ay madaling tingnan. Hindi ka na mag-compute. At meron ding pinapaliwanag ko palagi ay yung PHI or pre-harvest interval. Ito yung number, this is the number of days that the last time that you can use the kind of insecticide. So pag ikaw mag-harvest ng 110 days at sinasabi na ang chlorpyrifos at cypermethrin na insecticide ay may 50 PHI, ang ibig sabihin 110 minus 50, ang huli mong paggamit ng insecticide na ganito ang klase ay 60 days after flower induction. Dahil kung hindi, pag in-examine ang produktong yon, meron pa po siyang lason na maaaring makasama sa kakain. And if we want to reduce the number of times of pesticide application, we should practice bagging. I know this is quite expensive. And some people who are engaged now in mango bag earlier. So kung 50 centimos ngayon ang pag-ibabag ng mangga, pag nagbag ng maaga, halimbawa nagbag ng 40 instead ng 50, mahigit sa 20 o 25% ng ibabag ay malalaglag. At iyon ay natural na pagkalagas ng bunga. Hindi po yun mapiprevent. Kaya kung meron kang binalutan na 100 at 50 centavos ang ano. So meron kang 50 pesos na investment sa 100 na bunga. Siguro ang ano na noon ay sigurado na doon na ang 1/4 ng 50 pesos ay mawawala. Kaya hindi lang 50 centavos actually ang computation ng bagging. Ilalagay mo doon yung mawawala na nalaglag. Yun ang magiging cost ng bagging. Kaya mahal ang pagbabag. At nagiging mahal ang ating mangga. At ang consequence nito ay hindi tayo nagiging globally competitive. Natatalo tayo dahil ang production cost natin ay nagiging per kilo ay mas mahal, di hamak sa ginagawa ng Indonesia, ng Thailand at ng Vietnam. Talo tayo when it comes to global competitiveness dahil masyado tayong malaki ang ating ginagastos sa ating pagmamangga, pag-produce ng mangga. Okay, another way that we have seen is mulching. Pinag-aralan namin ito. Ang problema sa mulching, effective siya. Nakokontrol niya ang population. Ang problema sa mulching ay dapat mong gawin ito sa buong manggahan. Kaya kung ektarya ang iyong manggahan, libo-libong sako ang kailangan mo nitong kusot ng palay para takpan siya. Maraming advantages din ito dahil pag ito nabulok, magiging lang siyang parte ng lupa. At ngayon, pinapag-aralan namin kung yung mga mulching ay makakatulong para alagaan yung mga natural enemies. Ito ay, at syempre, pag nahulog, maraming pumatak na bunga, nahulog dahil sa Cecid fly. dapat itong simutin. Bakit? Lalo na kung papalapit na malaki na ang bunga. Ang nabubulok na bunga ay mabango para sa mga ibang insekto. Nag-a-attract siya ng fruit fly at iba pang insekto papunta sa inyong manggahan. Kaya pagkatapos ng Cecid fly, pwede kang magkaroon ng fruit fly dahil doon sa mga pumatak, mga nahulog na bunga, pag hindi po yun naitapon, yun ay nakaka-attract ng mga fruit fly sa manggahan. To summarize, meron po akong 5 rekomendasyon. Start or monitor Cecid fly starting at 32 Daffy and apply insecticides based on recommendation sa dami at dalas ng pag-i-spray. Kung ano lang po ang rekomendado. Practice IRM or what I would say, alternate the modes of action. Pwede nga sigurong gawing rule of thumb na ang mode of action, lalo na sa fruit development, ay huwag ulitin. Pag ginawa nyo yun, sigurado kayong makakakontrol ng Cecid fly. And as much as possible, reduce pesticide use because we need to conserve the natural enemies. Ang problema kasi, pag abot ng 40 Daffy, nakita na may kurikong, naku, gigil na gigil. Halos araw-araw na ang pag-i-spray or every 2 days, every 3 days. Nang gigigil, siyempre, kasi gusto nating i-save ang ating mangga. Pero kasi kung sabi ko nga, pag inabutan ka ng masama ang tama sa 40-45 Daffy, 50-50 na ang iyong chance na ma-save ang iyong prutas. And lastly, we should complement spraying with bagging, mulching, and sanitation. Marami pong salamat.
Marami pong salamat.
At gusto ko rin pasalamatan ang mga farmer cooperators ko. Dito po ako nagpupunta para maglagay ng mga eksperimento mula Bulacan, Pampanga, Nueva Ecija, South Cotabato, Pangasinan at Zambales. At syempre, ito sila sa Pampanga, sa Nueva Ecija, sa South Cotabato, sa Pangasinan. At gusto kong pasalamatan ang aking mga magigiting na kasamahan sa IWEP Insect Ecology Lab at sa NCPC. Marami po salamat.
Maraming salamat po, Ma'am Celia, for the presentation po. Mukhang marami pong mga kasama tayong sa audience, mga mango growers po na maraming siguro po sila natutunan at na-realize, especially po dun sa mga kung bakit nahirapan po silang i-control ang mango Cecid fly. So, Ma'am, this time habang nagdi-discuss po kayo kanina, ninote po namin yung ilan sa mga questions po ng ating mga audience po, Ma'am. So, yung iba po sa kanila ay banggitin ko po, Ma'am, and we'd like to hear your answers po from these questions po. So, una po, Ma'am, so kanina nabanggit niyo po yung mga iba po pong alternative control for Cecid fly. So, yung mulching nabanggit niyo po, yung fruit bagging. How about, Ma'am, yung paggamit daw po ng organic insecticide? Okay po ba yun?
Okay. Ang paggamit ng organic insecticide ay okay yon. Dahil alam niyo, kung palaging yung kanilang ipinapaliwanag ko na pagpapalitin ang MOA, pwedeng ang isa doon na MOA ay isang organic insecticide. Ang problema natin sa organic insecticide ay, ang tanong ko ay, dapat organic din ang fungicide na ihahalo mo. Dahil kung hindi, baka mag-negate. Kasi madalas ang ginagawa ng mga farmers, ng mga mango contractors, ay pinaghahalo ang insecticide at ang fungicide. Pag ginamitan mo ng organic, gawin mong organic lahat yung mixture para hindi nagkokontrahan. Baka mamaya gumamit ka nga ng organic na insecticide, makokontra naman siya ng hindi organic na fungicide.
Okay po ma'am, thank you po. Isa pa pong question ay ano ba daw po ang pwedeng gamitin as buffer zones? Or intercrop ma'am, pwede po, ma-advise po ba yun?
Aha. Ang buffer zone ba, ito ba yung buffer zone yung sa gili, ay yung sa bakod
Paligid,
o ang sa bakod?
Opo, parang
sa
ganun
bakod
po.
o intercrop. Actually, ang mangga ay kung sa intercrop, tanungin na lang natin kasi baka hindi natin ma-verify. Kung intercrop, ang intercropping sa mangga o lalo na yung pagbubungkal, yung pag-aararo sa pagitan ng mangga ay minsan delikado. Magandang gawin ito pag maliit pa ang iyong puno, pwede pa siyang gawin. Dahil meron pang yung canopy, pagitan. Ang problema nun, pwede mong masugat ang ugat. Pag nasugat ang ugat, pinapasukan siya ng isang klase ng sakit na tinatawag nating Phytophthora. At pag yan nagkaroon ng nakita niyo ba yung mga puno na lumuluha, na parang may tinaga-taga, lumuluha yung mga trunk. Yan ay Phytophthora. Yan ay pumapasok sa mga ugat. Nakakapasok siya sa puno, sa mga ugat through the wound na maaaring. Yun ang problema sa intercropping. Yung buffer para sa Cecid fly ay hindi ko kayang sagutin. Kasi ganito, may mga kaso akong nakita na sementado ang paligid kasi nasa resort yung mangga. Sementado ang paligid pero may Cecid fly pa din. So, kung ang sasabihin natin ay puprotektahan natin na makapasok sa manggahan, hindi po yun sigurado. Hindi ko po yun nakikita na paraan para pang-buffer against Cecid fly. Kasi masyado siyang maliit at sabi ko ay active po siya pag hindi maliwanag. At kung mahangin, pwedeng-pwede siyang dalhin ng hangin. Yun po ang masasabi ko dito.
Okay, ma'am, thank you po. Ma'am, regarding naman po sa fruit bagging, ilang days daw po pala dapat mag-fruit bag? Okay.
It is an argument. Argument yan ng gaano kadami ang kaya mong maikalugi. Ang rekomendasyon ay 50 Daffy. Dahil pag 50 Daffy, kokonti na ang kaya mong, kokonti na ang babagsak pa na bunga. Pag binalot mo siya, actually sa 50 Daffy, may 20% na fruit fall pa yun. Pag binalot mo siya ng 40 Daffy, para makaligtas sa Cecid fly, taasan mo yan. Kaya pag tingin ko yan, pag nakakita ako ng 30 to 40% na nahulog, normal lang yon. Kasi talagang marami pang mahuhulog mula sa 40 Daffy. Ang 50 Daffy nga na kung saan nire-recommenda dati na ang pagbabalot, makakakuha ka na ng 20% fruit fall. Mas lalo na pag binalot mo siya ng mas maaga. Ngayon ang tanong, gaano ang matsisave mo na insecticide at gaano ang napoproject mo na presyo ng mangga sa pagbebenta, saka mo masasabi na, kasi ang iba, pumupunta sa pagbabalot ng mangga ng maaga ng 40 Daffy. Kasi kung maganda naman ang presyo sa dulo, mababawi niya ang nagastos niya dahil mababawasan din ang kanyang insecticide application.
Okay, ma'am. So, next question po. Alam ko po, ma'am, yung ating topic ngayon ay naka-focus po sa Carabao Mango po. Pero may nagtanong lang pong isang viewer po natin na meron po bang ibang variety ng mangga na umaatake din po ang Cecid fly or meron din po bang resistant po sa Cecid fly?
Okay. Kung titingnan, although inaatake ang Indian mango, siguro inaatake ang Indian mango kasi ang Indian mango makapal ang balat. At ang Indian mango ay waxy. Mas waxy ang balat kesa sa ating kalabaw. Pero nakakita na rin ako ng inatake ng Cecid fly na Indian mango. Siguro dahil walang-wala na siyang makain. Kaya siguro siya umatake na ng Indian mango. Ano?
Okay po. Ma'am, ito naman, question po ay, safe pa din daw po bang kainin ang mangga na inatake na ng Cecid fly?
Palagay ko naman kasi tanggalin mo lang yung balat, pwede pa siyang kainin. Huwag lang siyang napaliguan mabuti ng insecticide. Ang pagiging ang safe naman minsan hindi natin kayang i-judge sa itsura. Na dahil nga ang pinoproblema natin kung pinaliguan siya ng gusto ng insecticide, hindi na siya safe. Pero kung dahil lang sa kurikong, yung mga panglabas, mababalatan siya at pwede pa siyang kainin.
Tanggalin lang po natin ang balat. Okay, ma'am. Next question, ma'am. Ano pong pwedeng gamitin o pwedeng bilhin na spreader sticker na available daw po sa market?
Ang FPA po ay may kanyang listahan. Ngayon ay hindi po kasi maganda para sa akin ang nag-i-endorso. Kung pupunta kayo sa inyong tindahan at magtatanong kayo, pabili po ng spreader sticker. Meron pong iba't ibang klase ng spreader sticker na available sa mga tindahan ng pestisidyo.
Okay po. Next question, ma'am. Sa gabi po ba talaga sila umaatake?
Hindi po sa gabi. Ito po ay umaatake pag nagtatakip silim. At alam niyo ba na kahit sa kalagitnaan ng araw, pwede siyang maging active. Pwede siyang lumipad ulit. Kung makulimlim. Yung cloudy na bandang December, January, marami tayong cloudy days at mga makulimlim. Pag makulimlim na ganun, kahit alas 11 ng umaga, nakakita kami ng Cecid fly sa alas 11 ng umaga. Pero normally, hindi yan active. Siguro nalito siya. Kala niya takip siling na kasi madilim Dahil cloudy at malapit ng umulan na Kaya hindi po siya sa gabi. Sa gabi, binantayan na yan namin. Sa gabi, natutulog din po siya paggabi. So yung maiksing panahon nag-aagaw ang dilim at liwanag, dyan po siya active. Dyan siya umaatake.
Okay po. So siguro last question na lang po yung kung ang Cecid fly daw po ay parang lamok, ma'am, pwede daw po ba ang fogging?
Okay. Ang fogging, ang isipin niyo sa fogging ay kaya niyang pumatay lamang sa panahon na nandoon ang usok. So kung may Cecid fly, kung kailan merong usok, mamamatay yon. Ang problema, maraming problema sa fogging. Pag mahangin, mahirap i-control yung usok. At ang problema din, hindi po yan rekomendado sa agricultural crop. Wala po tayong insecticide na registered sa FPA para gamitin sa fogging. So yan po ay off-label. At meron po yung epekto sa nag-a-apply at nakakasinghot. Dahil ang insecticide sa fogging ay mas pino pa kesa sa mga yung halos hangin na lang siya Kaya ang nag-a-apply nito ay delikado at ang mga tao sa paligid na nagpa-fog. Kaya pag nag-fog tayo, pinaalis ang mga tao. Kaya hindi ko po gustong i-rekomenda ang fogging. at dahil wala pa pong registered na insecticide para sa fogging.
Okay po. Maraming salamat po, Dr. Celia Medina, for unang-una po yung na-share nyo po sa presentation nyo po kanina. Maraming salamat din po sa time po sa pagsagot po ng mga questions ng ating mga viewers. Alam ko po madami pa pong mga ibang questions ang ating mga audience ngayon, pero subukan po namin yung best namin na mabalikan po namin lahat ng mga questions nyo po. So, yung isa sa mga feedback po na nakukuha po namin ay yung tungkol po sa guide. So, marami pong interesado na kung paano po sila maka-access do sa guide. So, katulad po na na-share po ni Ma'am Celia po kanina, pwede nyo pong bisitahin yung mango-irm.com o kaya po antabayanan nyo po sa aming pong Facebook page or website ang impormasyon po tungkol po dito sa guide na ito. May question din po kanina kung nagpo-provide po ba ang bar po ng e-certificates. Yes po, magbibigay po kami ng e-certificates. Magpo-post lang po kami ng link ng online feedback form po sa aming pong Facebook page. Pakisagutan lang po itong form na ito at tapos po nun ay magbibigay po kami ng e-certificate. Isa pa pong question na nakuha po namin at marami po yatang interesado makakuha ng presentation po ni Dr. Medina. So with the permission po of Ma'am Celia, yung pong yung pong PowerPoint presentation po na ginamit po ni Ma'am Celia ay upload po namin sa website po namin. Ang website po ng BAR ay www.bar.gov.ph. Ayan po. Ano pa po bang mga ibang feedback? So ayun, yun pa po pala, bago po tayo mag-end, baka po meron pa po kayong mga iba pa pong suggested topics po para po sa ating free seminar. Makikisuyo na lang po na i-comment nyo po sa comment section ngayon o kaya po ay i-message nyo po kami sa aming pong Facebook account. So once again po, Ma'am Celia, thank you very much for your time and for the information po na share nyo. Maraming salamat po sa ating po mga audience na nagstay po at mukhang very engaged po sila sa ating topic for this morning. At nawa po makita po namin kayo ulit sa aming susunod po na free seminar. Magandang umaga po ulit sa atin and keep safe po sa ating lahat.